The topic is adding integers. The objectives in this topic are add integers, evaluate an algebraic expression by adding, and solve applications by adding integers. Adding integers can be visualized by using a number line. A positive number can be represented on the number line by an arrow of appropriate length pointing to the right, and a negative number by an arrow of appropriate length pointing to the left. So let's add using a number line, -2 plus -3. We'll start at 0. And then the first number is -2. We will move left 2 units. The second number is -3. So from where we stopped, we will move left another 3 units. We ended up at -5. So the answer is -5. Another one where we could use a number line, -8 plus 3. Start at 0. The first number is -8, so that's left 8. The second number is +3, so from where we finished, we go right 3. We end at -5. Once again, we have an answer of -5. Now, we don't want to do every problem with a number line. We can visualize it in general with the number line. For instance, how much we go left, how much we go right. Do we finish positive? Do we finish negative? But as the numbers get bigger, the counting method becomes less and less useful. So we need a system that we could use for every possible addition. We're going to break it up into 2 different rules to follow. One, when the 2 numbers we're adding have the same sign, and one when the 2 numbers we're adding have different signs. For starters, when we're adding with the same sign, we add the absolute values and then use the common sign as the sign of the sum. So -14 plus -9. We're adding, they have the same sign. They're both negative. Take the absolute values. The absolute value of -14 is +14. The absolute value of -9 is +9. And then add those absolute values. 14 plus 9 is 23. The common sign was negative, so we give negative to that 23. -23 would be the answer. On the other hand, if we're adding 2 numbers with different signs, we're still going to start with the absolute values, and we're going to subtract the larger absolute value minus the smaller absolute value. So subtract in the order that leaves it positive. Then whatever the sign of the number with the larger absolute value was, is the sign of the sum. -11 plus 18. One of these numbers we're adding is negative, the other is positive. Take the absolute values. The absolute value of -11 is +11. The absolute value of +18 is +18. Subtract those in the order that makes sense, the order that keeps things positive. That's 18 minus 11. That gives us 7. So our answer is either going to be +7 or -7. It's going to depend on what was the sign of the number that had the larger absolute value. The absolute values were 11 and 18. 18 was the larger absolute value. 18 originally came from a positive number. So the sum is positive. Our answer is +7. On the other hand, if we have 8 plus -13, The absolute values are 8 and 13. 13 minus 8 is 5. But the larger absolute value was 13. 13 came from a negative number, so our answer is negative 5. Some practice. Negative 21 plus 12. The 21 is larger, so our answer is going to be negative. 21 minus 12 is 9, so negative 9. In B, the 22 is larger, so our answer is going to be positive. 22 minus 9 is 13, so positive 13. C, the 12 is larger, the 12 is negative. 12 minus 0 is 12, so negative 12. If A is a number, then the opposite of A is its opposite. Also, a number plus its opposite is 0, and the opposite plus the number is 0. In other words, the sum of a number and its opposite is always 0. For example, negative 25 plus 25, that's the sum of a number and its opposite. That's 0. 72 plus negative 72, that's the sum of a number and its opposite. That's 0. Here's another example. We want to add 5 plus negative 7 plus 3. You can see that we're just going to work from left to right. First, we do the 5 plus negative 7, and we get negative 2. Then we add 3, and we get positive 1. So to break that down a little more, 5 plus negative 7. The 7's larger, the 7 is negative, the answer will be negative. 7 minus 5 is 2. We get negative 2. Negative 2 plus 3. The 3 is larger. The 3 is positive. The answer will be positive. 3 minus 2 is 1, so positive 1. Another evaluate problem. 3x plus y for x equals 2 and y equals negative 6. We make our replacements. Plug it in, plug it in. X equals 2 means instead of 3 times x, we have 3 times 2. Y is negative 6, so plus y becomes plus negative 6. 3 times 2 is positive 6. 6 plus negative 6 is the sum of a number and its opposite. That's 0. Wrong way. There we go. Finally, a word problem. The temperature at 4 p.m. on February 2nd was negative 10 degrees Celsius. By 11 p.m., the temperature had risen 12 degrees. Find the temperature at 11 p.m. If we break this down, we're starting at negative 10, and then we're adding 12. Negative 10 plus 12 would give us positive 2. The other way to think of this is start with the end temperature. Actually, give me a second. There we go. I wanted to make sure we had that negative 10 plus 12 equals 2 written there. because I wanted to show that this is the exact same logic that we used. The absolute values are 10 and 12. Subtract them, 12 minus 10. The larger number was 12. That one was positive. So positive 12 minus 10 is 2. What this has written out down here is the same thing. We take the absolute values and we subtract them. And it stayed positive because the 12 was the bigger number and the 12 was originally positive. But yeah, at 4 p.m. we're at negative 10. Then we add 12. We could also think of a number line. Start at 0, go left 10. You're at negative 10. Go right 12. You pass 0 and you end up at positive 2. And that is it for this lesson and this topic.